All right, so one of the things that I've learned throughout my years of teaching in math is that my students really like to have a step-by-step procedure if possible. It's very hard to have one in this procedure. Practice should replace your step-by-step. You should do this so many times that you don't need the step-by-step anymore. You just look at the graph and you do the steps in your head. But if you want to have it written down on paper to start off, here's your procedure. When you look at the graph of an exponential function, the first thing you're going to do is draw in the horizontal asymptote. Then you're going to plot the point on the curve 1 unit up or down from the horizontal asymptote, right? So you're either going to go up or down depending on whether the curve is above or below. Then you're going to move along that line, that's 1 unit up or down, until you hit the curve, and that is the point. The point is always vertically 1 unit above or below the asymptote. Then, from the point, you're going to identify the base. Remember, you have to go 1 unit over from the point to where you're between the asymptote and the curve, and then you have to measure the distance. That's what I'm going to write right here. The distance between the asymptote and the curve. 1 unit over from the point. 1 unit over from the point, okay? Sideways, 1 unit sideways from the point, okay? Then what you're going to do is you're going to identify their left or the right shift, okay? And the way you're going to do that is based on how far the point is from the y-axis, right? And you're going to put that left or right shift with the x in parentheses in the exponent. And remember, this one is going to have an opposite sign, okay? So if it's a positive 7 shift to the right, you're going to put a minus 7 with the x in parentheses in the exponent, okay? Then you're going to identify the up or down shift based on the vertical shift of the asymptote, okay? So if the asymptote is 9 units below the x-axis, that's a minus 9. Where are you going to put the minus 9? You're going to put it at the end of the expression as a plus or a minus. Okay, you are not doing the opposite sign here. You're going to do what you see is what you get. If it's a minus 9 shift, you're going to put minus 9 on the end of the expression. If it's a plus 7 shift, you're going to put a plus 7 at the end of the expression. Lastly, you're going to put on negative symbols based on reflections. If it's the normal shape, flat on the left, steep on the right, and it's above the asymptote, no negatives. If it's upside down, where it's flat on the left and steep to the right, but it's below the asymptote, you're going to put a negative on the front, right? If it's backwards, where it's flat on the right and steep on the left, you're going to put a negative on the exponent. And if it's both upside down and backwards, you're going to put a negative on the front and on the exponent, okay? So we're going to use this procedure right now and do maybe 5 or 6 examples to try and help you understand how to recognize a graph based on vertical and horizontal shift. All right, so here's our first example, okay? It's definitely shifted up or down. It's definitely shifted left or right. If I were to just look at the graph of this curve and someone said, hey, what's the equation of this graph? I might be a little freaked out if I hadn't learned all the things that I've just been teaching you in these lessons, okay? All right, so the first thing we're going to do is we're going to draw in the asymptote. Here's the flat part of the curve, so this is where we're going to put the asymptote, right here. Okay, then we're going to plot the point on the curve 1 unit up or down. Well, this curve is below the asymptote, so it's going to be 1 unit down. So I'm going to go 1 unit from the asymptote down, and along this horizontal line, I'm going to move over, and boom, there's the curve. So I'm going to plot that point, okay? It is 1 unit below the asymptote, right? Here's the asymptote. 1 unit below is the curve. That's our point, okay? All right. Now, you know what I'm going to do? I'm going to go ahead and identify the coordinates of that point. If you were to identify the coordinates there, we would start at the origin and go positive 1, positive 2, positive 3, positive 4. So our x-coordinate is 4, and then positive 1, positive 2. So this is at the point 4 and 2. And I want you to see how this is going to play into understanding our equation, okay? All right, so now we're going to identify the base. So to identify the base from the point, we need to go 1 unit over from the point, sideways, has to be sideways. We're going to go over this direction because we want to be between the curve and the asymptote. Then we're going to go vertically to the asymptote, which is right here. And then from there, we're going to vertically count the distance to the curve, which is here. That's a distance of 2. Therefore, this exponential function has a base of 2. So we know that it's going to be f of x is equal to base of 2. That's where we're starting. Okay. Also, we know that there's going to be an exponent in parentheses with an x in it, right? So now it says identify the left or right shift, and you're going to put it with that x in the parentheses, right? All right, well, normally this point is at the y-axis right here, okay? And so we want to count the distance of this point from the from the y-axis. That's 1, 2, 3, 4. Well, that's actually the x-coordinate, and it always will be the x-coordinate with exponential functions. And so this is a positive 4 shift, but we want to make it the opposite sign. So instead of plus 4, it's going to be minus 4. So we're going to put a minus 4 on the x. Now we're going to do the vertical shift. It says identify the up or down shift based on the vertical shift of the asymptote. Well, normally the asymptote is on the x-axis. So this asymptote is 1, 2, 3 units above the x-axis. Therefore, that is a plus 3 shift, which we will put on the end of the expression. So we'll just put a big old plus 3 here. And now the last thing we need to know is, do we need to put any negatives on? Well, first of all, I can see the curve is below the asymptote. Instead of above it, the curve is below. That's out of the ordinary, okay? That's a vertical shift, which puts a negative on the front of the function, on the front of the expression. Lastly, the normal shape is flat to the left, steep on the right. This one is flat on the right, steep on the left. Therefore, this curve is backwards. Backwards means I put a negative on the exponent. And therefore, the function, the equation of the graph of this exponential function is f of x is equal to negative 2 to the power of negative quantity x minus 4 plus 3. Okay? This is our exponential equation. Now here is how you would write it in the box on the quiz. Okay, you would put in a negative, then a 2, then exponent symbol because we're going up into the exponent, then a negative, then a parenthesis, then an x, then a minus, then a 4, close the parenthesis, and then just simply roll right into the plus 3. And this is how you would enter it into the box on the quiz or on the exam. Negative 2 to the power of negative quantity x minus 4, and then the entire quantity is plus 3, shifted up 3. Okay? All right, I think we should do at least 3 or 4 more examples to help you get a good feel for this procedure. All right, here's another one. Now, if you feel like you picked everything up pretty well, why don't you pause the video now and try this on your own. All right, so let's go ahead and work out these steps here. First thing I'm going to do is draw in the asymptote. So I'm going to draw in the asymptote right here. Okay, I can already see that there is a negative vertical shift. It's gone down from the x-axis. Okay, now I want to plot the point. The curve is above the asymptote. Therefore, I'm going to go up 1 unit from the asymptote and over to where the curve is. Boom, there's my point right there. Now, from that point, I'm going to go 1 unit over because I want to identify the base of the exponential function. So 1 unit over to where I'm between the asymptote and the curve. I am. Then I'm going to go down to where the asymptote is right here and measure the distance from the asymptote up to the curve. Boom. Now that distance is more than 2, less than 3, but closer to 3. That means that this is a base of e. Okay? All right, now I've got my base. Okay, so I'm going to put f of x is equal to, and I know that it has a base of e. Now I want the left and right shift, which is going to be put in the exponent with an x. Okay? All right, well, this point right here, how far is it from the y-axis? It's 1, 2, 3, 4, 5, 6 units from the x-axis, and it's in a negative direction. So it's a negative 6 shift. Opposite sign makes it plus 6. So this is going to be x to the power of x plus 6. Now I need my vertical shift. The asymptote is from the x-axis, it's going down. That's -1. See, this is -1, -2, -3, -4. This is -5. So the asymptote is at the vertical height -5. That makes this a -5 shift. Now, I need to put on negatives if there are any reflections of this curve. Well, this curve doesn't have any reflections. It's flat on the left, steep on the right, and it's above the asymptote. Therefore, this is the normal shape of the exponential function, and therefore we're not going to put any negatives on. And so if we were writing this in the box on the quiz, we would put e to the power of parenthesis x plus 6, close parenthesis, then -5. This is the equation of this curve, okay? A few more examples. All right, this one's a little crazy looking, but I think you can figure it out. Okay, you can see the x-axis is all the way down here, and here's the y-axis, okay? You want to try and pause the video and try it on your own? All right, so the first thing I'm going to do is I'm going to draw in the horizontal asymptote. You know, if you wanted to, you could be a ruler kind of person, so maybe I'll use a ruler this time. Okay, go ahead and draw in the horizontal asymptote. Oops, I just drew on my ruler. It's okay. It's a dry erase marker. It'll come off. See? Whoop. There it goes. Very nice. Okay. All right, so I've got my horizontal asymptote drawn in. Now I need to plot the point. Well, the point is going to be either 1 unit up or 1 unit down from the horizontal asymptote. The curve is above the x-axis. Excuse me, it's above the asymptote. It's also above the x-axis, but it's above the asymptote, so I'm going to go 1 unit up from the asymptote, and I want to travel sideways to where I hit the curve, which is right here. That makes this the point, right? Then I'm going to identify the base of this exponential function. And the way I'm going to do that is I'm going to go 1 unit over from the curve. Now this throws people off sometimes. Look, when I go 1 unit over from the point to here, it's actually on the y-axis. That's okay. It's okay if I have to go vertically along the y-axis to identify the base. The only problem is that sometimes it looks weird when you're looking at the graph, but it's fine. Ignore the y-axis. This is where we want to be. I got to go down and start at the asymptote. So 1 unit over from the point, go down to the asymptote, then from here vertically measure 1, 2, 3, 4, 5, 6. Not quite there. Here it is, 7. The base of this exponential function is 7. By the time I get to 8, the curve is to the left. Down here at 6, the curve is still on the right. But right here at 7, it's passing right through there. It's passing right through that point. So the distance from the asymptote up to the curve vertically, 1 unit over from the point, is 7. Therefore, this exponential function has a base of 7. Okay? Now we want to know the left or right shift. We know that's going to be in parentheses with an x in the exponent. Okay? And so we're going to go left or right shift. We go to the point, and how far is the point from the y-axis? Well, it's 1 unit over from the y-axis. The y-axis is right here. So that's a +1 shift from the y-axis, but we need the opposite sign, so that makes it -1. So we're going to put x -1 because it's 1 unit to the right of the y-axis. Now our vertical shift, well, here's the x-axis. The horizontal asymptote is +1, 2. It's 2 units above the x-axis, so we're going to put a +2 on the end. Now we need to put any negatives on for the reflection. Well, it's not reflected vertically because the curve is above the asymptote, so there's no negative on the front. But instead of being flat to the left and steep to the right, this one is flat to the right and steep to the left. So we know that this is a backwards reflection. That means we put a negative on the exponent. So in front of the parenthesis, we put a negative there. And so therefore, this curve is the equation. It's the function f of x is equal to 7 to the power of negative quantity x minus 1 in parentheses, then +2. Okay? And on the quiz, you would enter in the box 7, then you'd put an exponent symbol, then a negative, then a parenthesis, x minus 1, close parenthesis, then +2. Okay? And this would be the correct way to enter this exponential function in a fill-in-the-blanks box. Okay? Let's just do a couple more examples. All right, here we go. We have another graph. If you want to try and pause the video and figure this one out on your own, give it a shot. All right, so the first thing I'm going to do is draw in the horizontal asymptote. Here's my flat part right here, so I'm just going to put my dashed horizontal asymptote along this flat part, and then I'm going to extend it straight out along this horizontal line. There's my asymptote. Now I need to identify the point, right? So for the point, I'm either going to go 1 unit up or 1 unit down from the asymptote. I know I'm going to go 1 unit down. Why? Because the curve is below the asymptote, right? So 1 unit down along this horizontal line, which just happens to be the x-axis, and that's okay. I'm going to travel along this horizontal line 1 unit down from the asymptote until I hit the curve. Boom, there's the curve. That's the point. It is okay for the point to be on the x-axis or on the y-axis. That's fine. Now, if the point is on the y-axis, that means it doesn't have a left or right shift, okay? But this definitely has a left or right shift because that's not on the y-axis, okay? All right, now we need to know the base. To identify the base, we're going to go 1 unit over from the point. Then we're going to go vertically to where the horizontal asymptote is, which happens to be up here. And then vertically, we're going to measure the distance down to where the curve is, not at 2, and it stops before 3. There we go. Do you see it right here? It's right there. All right? Because at 3, it's over here. At 2, it's over here. So that must be e because it's between 2 and 3 and it's closer to 3. So the base of this exponential function is e. So we'll put f of x is equal to e, right? Now we're going to identify the horizontal shift, which is going to be in the exponent in parentheses with an x, okay? This point right here is, how far is it from the y-axis? Well, it's 2 units over. That's a +2 shift from the y-axis. This was shifted to the right 2 units. But we're going to put an opposite sign. Instead of a +2, we're going to put a -2. So this is x minus 2, right? Now the vertical shift, here's the x-axis. Do we have to go up or down to get to the horizontal asymptote? We got to go up. How far up? Just 1 unit, so it's a +1 shift. So put a +1 on the end. Last thing is we need negatives. Is this upside down? Yes, it's upside down. Instead of being above the asymptote, it's below the asymptote. Therefore, it's upside down. It gets a negative on the front. Is it backwards? It is not backwards. Normal is flat to the left, steep to the right. This is indeed flat to the left, steep to the right. It is not backwards. Therefore, we do not put a negative on the exponent. If we were going to write this in a fill-in-the-blanks box, we would say that f of x is equal to negative. I just hit the letter E on the keyboard. Negative E. Now we're going to the exponent, so I'd have to put the exponent symbol, which is the caret, okay? And then I'd put parenthesis x minus 2. Be sure to close the parenthesis, and then after the close of parenthesis, just put a +1, and that is our equation. So this is the function for the curve that we're seeing here. Negative e to the power of x minus 2 quantity, and then +1, okay? Now we're going to do maybe just one more example. All right, here's your last example. And then what I would do is, I'm going to give you several graphs on a PDF with, blank, well, not blank, there'll be the graphs, but then there'll be a separate PDF that has all the answers. So you'll have plenty of practice with doing this before you take the quiz. Also, there will be the practice quiz, so you should be fine there. All right, so first thing we're going to do is draw on the horizontal asymptote. Here's the flat part right here. So here's the horizontal asymptote. I like drawing from left to right. It's a little easier for me. So I'm going from the right over to the left, then drawing the asymptote. So there's my asymptote. I don't have to go too far, really. Now I need to plot the point, so I'm going to go 1 unit down because the curve is below the asymptote. So I'm going to go 1 unit down from the asymptote, and I'm going to travel sideways over to wherever the curve is, which is over here. There's the point. Plot the point. Now I need the base, so I'm going to go 1 unit over from the point, then go back up. It could be up, could be down, but in this case I have to go up to where the asymptote is, and from there I'm going to vertically measure the distance to where the curve is, which is right here, okay? There's the vertical, and I'm going to count 1, 2, 3, 4. This has a base of 4. So my equation is going to be f of x is equal to base of 4, okay? Now I need my exponent, which is going to be in parentheses with an x, okay? Now I need my horizontal shift. Well, here's my point. How far is the point from the y-axis? Well, it's 1, 2, 3, 4, 5, 6, 7 units to the left. That means a -7 shift, but I'm going to put the opposite sign. I'm going to put plus 7. X plus 7. Now my vertical shift, here is the x-axis, and the asymptote is above the x-axis, so I got to shift up 1, 2, 3, 4, 5. So I'm going to put a big plus 5 on the end. Notice that this plus 5, the exponent is tiny and superscript, okay? The plus 5 on the end is a regular sized plus 5, same size as the 4 and on the same level as the 4, okay? So plus 5. Now I just need to put in my negatives. Well, this graph is below the asymptote, so it's upside down. That's going to give it a negative on the front, okay? And it's flat to the right and steep to the left instead of the normal, which is flat to the left and steep to the right. So this is backwards. Therefore, we're going to put a negative on the exponent, okay? And if we were going to type this into a box, we would type it in as put a negative, then a 4, then an exponent symbol, then negative, then parenthesis, then x plus 7, then close the parenthesis, then plus 5. And this is how we would enter it into a box, okay? And so that's it. This is everything you have to know about identifying the graphs of exponential functions. And now what we're going to move on to, last couple lessons, are going to be the exact same thing, only with logarithmic functions, okay? We're going to do the graphs of logarithmic functions, and then we're going to learn how to identify the base. We're going to learn how to identify vertical, horizontal shifts, all the exact same stuff. It's very similar, but with logarithms, it's basically turned sideways, or it's shifted about 90 degrees and backwards, because logarithms are the inverse of exponentials, okay? All right, that's it you need to know for this particular lesson. Good luck on the practice. Good luck on the quiz.